Connolly. I started making these videos for my 5th graders and this one is for them. But I want to make sure as many students are learning as possible. So teachers, parents, students, get the word out. Let's get as many kids learning math before next year as we can. If you have any questions or topics you want me to cover, connollymathathome@gmail.com. Before I start this video, I want you to know that I just recorded one called Introduction to Dividing by Powers of 10. And it's really important that you watch that one so you understand what's going on before we get into division with decimals. So in this video, I am going to go over when the divisor gets 10 times smaller, what happens to the quotient. I went over this in the other video, but I just did it with the digit 1. So I was dealing with 1 and 1/10, and now we're going to start thinking about what's happening when the digit is not 1. For example, when we're dividing by 4, if we're dividing by 4/10, if we're dividing by 400ths. Okay, so let's get started. When we are working with dividing by decimal, we really want to be thinking about what's happening also with whole numbers. That is a strategy that we're going to be using to solve. Okay, so let's give a story problem context. I have run 12 miles. I did 4 miles per day. How many days did it take me to run the 12 miles? Okay, so I have 12 miles. I'm splitting them into 4 equal groups. I'm wondering how many groups do I have? So with whole numbers, we can think about it like we would think about any other time. I also want to point out that there's a relationship between multiplication and division, and this is going to be really important for us checking our answer and making sure the decimal's in the correct place when we're done. So when we think about 12 divided by 4 equals blank, we're thinking about how many groups of 4 equals 12. Okay, so this can also be written as how many. The multiplication symbol stands for groups of. How many groups of 4 is equal to 12. Okay? And I'm going to show you on the number line. The reason for that is because I'm going to show you what's happening when we do 4/10. Okay? So on the number line, when we're thinking about how many groups of 4 in 12 miles, I'm going to count by 4s. 4, 8, 12. How many groups of 4 were there? 1, 2, 3. 3 groups of 4 makes 12 miles. Okay, so 12 divided by 4 is 3. Now, we're going to be thinking about if I ran 12 miles and I only did 4/10 of a mile each day, how many days did it take me? And I want you thinking, if I was running 4 miles every day and it took me 3 days, and now I'm only running 4/10 of a mile each day, is this going to be greater than or less than 3? So you should be thinking about that. I'm going to write it as a multiplication situation over here. How many groups of 4/10 does it take to make 12? Okay? Before I even start, I really want to be thinking about making an estimate. Okay? So I'm going to estimate right now. I'm going to think about if this 4/10 is really close to 5/10, which is a half, I'm going to be thinking about estimating with a half. So how many groups of 1/2 make 12? Okay, so how many groups of 5/10 makes 12? This is my estimate. I'm doing this to help me place the decimal in the correct place and make sure I've done everything correctly at the end. I want to reason about the size of the numbers. So I know that in one whole, there's 2 groups of 1/2. So I know in 12 wholes, there's 24 groups of 1/2 in 12. And remember, that's just an estimate, okay? That's going to help me at the end to make sure that my answer is reasonable, that my answer makes sense. It's going to help me decide exactly what to do from here to here, okay? So let's think about this. I'm going to see how many jumps of 4/10 it takes me to get here. All right? So let's think. I'm not going to label them because that would take a really long time, but I'm going to say it out loud. 4/10, 8/10, 1 and 2/10, 1 and 6/10, 2 wholes. 2 and 4/10, 2 and 8/10, 3 and 2/10, 3 and 6/10, 4 holes. So I just did little jumps of 4/10 because my goal is to figure out how many groups of 4/10 are in 12. Let's count how many we've done so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It took me 10 groups of 4/10 to get to 4. So in this one jump, I have 10 groups of 4/10. So I know my next 4 miles is going to be another group of 10 groups of 4/10. Okay? Then I know I'm going to have to do another 10 groups of 4/10 to get the next 4 miles. So if I do 10 groups of 4/10 and then 10 more groups of 4/10 and then 10 more groups of 4/10, how many groups of 4/10 did I have to do? 10, 20, 30. So now I need to make sure that my answer is reasonable. I want to make sure that I've used all of the math understanding I have. Okay? So first, I estimated. I estimated that if I was dealing with 5/10, that there would be 24 groups of 5/10 and 12 miles. So I look at my quotient and I say, okay, that makes sense that there was 30 groups of 4/10 and 12 miles. That's very close. And I think about how much I rounded to make sure that's right. Okay, so my estimate checks out. Then I also want to make sure, and I'm going to erase some of this so that we have space. I also want to make sure that my multiplication situation makes sense. So is it true that 30 groups of 4/10 is the number 12? Well, if you need to go back and watch the multiplying by decimals, you can, but we're going to pretend that we're multiplying with whole numbers. And 30 groups of 4 is 120. I know that my factor got 10 times smaller, so my product gets 10 times smaller, or there's 1 digit to the right of the decimal, 1 digit to the right of the decimal. So I check 30 groups of 4/10, is it 12? And that makes sense. Okay, so I checked with my multiplication, and then there's one more great thing that you know that you can use. When we were thinking about 12 divided by 4 equals 3, we know that 4 got 10 times smaller, our divisor got 10 times smaller, so you saw the 10 jumps to make one of these jumps of 4. So when my divisor gets 10 times smaller, my quotient gets 10 times larger. And that makes sense because we were going 4 miles a day and it only took us 3 days. Then we dropped down and we just did 4/10 of a mile a day. The mileage we were doing got smaller, 10 times smaller. So how many more days did it take us? It took us 10 times as many days. Okay? So just be aware that there's going to be other situations where the dividend's getting smaller, the divisor is also getting smaller, so you're going to have to still use estimating and checking your multiplication to make sure it works, but if it's just the divisor getting 10 times smaller, you know your quotient is getting 10 times larger. Alright, so let's try another one, and we're going to use all the things we just talked about. So if we are thinking about 132 divided by 1 1/10. Here's what I'm thinking about. I've gone 132 miles. I've gone 132 miles total. I did 1 1/10 miles per day. How many days did it take me? Okay, so what are we thinking about with multiplication situation? We're thinking about how many groups of 1 1/10 does it take to go 132 miles? Okay? The other thing we need to think about is an estimate. I know that 1 1/10 is close to 132 divided by 1. So my estimate is going to be 1. Sorry, not 1, 132. I know my quotient is going to be somewhere around 132. So what do we do when we're trying to figure this out? We're going to do just what we did last time, where we thought about our divisor as a whole number. Okay, we're going to think about both the dividend and the divisor as a whole number when we're dividing with decimals. You can use any division strategy that you want, okay? But what I'm going to do, instead of thinking about 1 1/10, I'm going to think about the number 11. And then when I go to write my final quotient, I'm going to have to adjust what happened with the divisor. So currently I am thinking about, let me put my estimate way down here. So my estimate is here. Right now I'm thinking about 132 divided by 11. Okay? So a refresher with division strategies, I can think about 11 times 10 first. I'm going to subtract those 110 miles. I'm left with 22 miles. Then I'm going to do 11 more groups of 2 miles. So I know, and you can use any whole number division strategy you want. I just did that one quick. I know 132 divided by 11 is 12. So if it was 132 miles and I did 11 each day, it would take me 12 days. But that's not what happened. What happened was we only ran 1 1/10 mile per day. So what happened with our divisor? From our whole number strategy to here, our divisor got 10 times smaller. So I know my quotient has to get 10 times larger. Okay, and 10 times larger is 120. Now let me just make sure that makes sense. When I estimated, I said, I rounded down just a little bit, and I said 132 divided by 1 would be 132, but I knew that my answer was going to be slightly less because I ran just a little extra those days. Okay, so I have to check and make sure, does my answer make sense with my estimate? And it does. That's a reasonable situation. And then I want to make sure my answer makes sense with multiplication. So, does it make sense to say, and I'm checking with the standard algorithm to show you all the different things that you know, does it make sense to say 120 groups of 1 1/10 is 132? So let's just check this out here. Let me get rid of my estimate. Sorry, this board is so small. 0. Hold on. And then I know that this factor got 10 times smaller, so my product gets 10 times smaller. So I just double check with multiplication. Does it make sense to say 120 groups of 1 1/10 is 132? So does this make sense? And this makes sense. And it's close to my estimate. Then I know that I probably did something correct. Okay, we're going to look at one more example, and then I'm going to give you some to try at home on your own. Okay, so again, we divided 132 divided by 11 because we acted like we were using whole numbers. Okay, we thought about how the divisor got 10 times smaller, so our quotient got 10 times larger. We were running 10 times less of the distance each day, so it took us 10 times more days to finish the 132 miles. We checked with our estimate and we checked with multiplication. Everything made sense, so we know we put the decimal in the correct place. Okay, all right, last one that we're going to try together is 135 divided by 45 hundredths. Okay, so what are we going to do first? Well, we're going to make sure we have all the things ready to go. We're going to be thinking about this as if it's a whole number. Okay, then we're going to have to think about what happened from here to here with our divisor. How many times smaller did it get? Okay, that's one way we're going to think about it. The next thing that we're going to be thinking about is writing and checking our multiplication. How many groups of 45 hundredths to make 135? So we're going to check in there. Finally, we want to think about our estimate. So when I'm looking at 135 divided by 45 hundredths, in my brain, I think, well, 45 hundredths is really close to 5 tenths. And I like working with 5 tenths because it reminds me of 1/2. And so if I'm thinking about how many groups of 1/2 are in 135, I know for each whole there's 2 groups of 1/2. So I know for 135 wholes, there's going to be 2 groups of 1/2 in each. So I'm thinking double this. And that is my estimate to solve. Okay, I rounded up a little bit, so my estimate's going to be a little bit off, but I'm going to use that to make sure my decimal's in the correct place. So then, what do? We divide as if we're working with whole numbers. 135 divided by 45. Okay, so where do we want to start? I think I'll do 45 times 20 first. So that would, 45 times 2, sorry. 45 times 2 is 90, so I'm going to start there. And then I'm going to be thinking about how many more groups of 45 is there. Okay, if you were ready to do times 3 right at the beginning, you could. Again, showing you that there's several different ways to think about dividing with whole numbers. So, if 135 divided by 45 is 3, I have to ask myself how many groups of 45 hundredths makes 135. Well, 45 to 45 hundredths, how many times smaller did 45 get to go from 45 to 45 hundredths? Well, I'm just going to do a little scratch work down here. 45 hundredths represents 45 divided by 100. So I also know that my 4 used to be in the digit 4 was in the tens place. It got 100 times smaller and went to the tenths place. Okay, so 40 divided by 10 would have been the ones place, and then it went shifted over another place value. So it got 100 times smaller from 45 to 45 hundredths. Don't forget the fraction bar represents division. Okay, so if my divisor gets 100 times smaller, my quotient has to get 100 times larger. Okay, in the last 2 examples, the divisor had just gotten 10 times smaller. And then the quotient got 10 times larger. In this example, my divisor got 100 times smaller. So my quotient has to get 100 times larger. Okay, so what are we going to do? We're going to make sure that makes sense with my estimate. So 300, my estimate was 270. So does it make sense? Yes. This is where if you had written 30 and you had an estimate, you would have been like, wait a minute, something's off. Okay? Next thing, I want to make sure that my multiplication situation works out correctly. So I'm going to think about it like this. I know, well, I'll just do the standard out. No, I don't like that. So what I'm going to think about is I know 100 groups of 45 hundredths is 45. Okay, because it's 4,500 hundredths. Okay, so I know if I do that, see how I'm doing 300? I know if I do that 3 times, that's going to equal 135. Okay, so instead of doing the standard algorithm, I chose another strategy for checking my multiplication. I want to make sure that it made sense that 300 times 45 hundredths was 135. Okay, so I double checked my multiplication. So in all of these situations, here's what happened. We treated everything like it was a whole number. We divided 135 divided by 45 as if they were whole numbers. Then, from there, we thought about how much smaller is our divisor, and that's how much larger our quotient has to get. Okay? We also used an estimate to make sure that our answer made sense. We also checked with multiplication to make sure that our answer made sense. Okay? So I'm going to give you 3 to try on your own. You should be writing it as a multiplication situation. You should be dividing as if you're dividing whole numbers. You should be thinking about how much smaller did your divisor get, how many times smaller, so how much larger should your quotient get. You should also be checking your estimate. Okay, so, sorry this is not erasing great. The ones that you're going to try at home are 32 divided by 800ths. So, if I were you, I'd be thinking about 32 divided by 8 and then make the adjustment. Then you're going to be thinking about 108 divided by 9/10. Your estimate for this one, you know what 9/10 is close to. Okay, and then the last one, I want you thinking about 660 divided by 5 and 5/10. So if you take the decimal out of this and you're thinking about whole numbers, you would be thinking about 660 divided by 55, and then you should be thinking about what happened from 55 to your divisor and what should happen to your quotient. Okay? Use all the strategies at the same time. Remember what you learned yesterday in the introduction to dividing by powers of 10. Okay? Bye.